Today I'm going to teach you how to do the sensitivity analysis using ArcGIS and Microsoft Excel. So for the requirements, you should make sure that you already have your data, your reclassified raster data or layers. So this time I will be using my study, which I have 7 criteria. And we will be adopting the weighing schemes, this one, weighing schemes for our sensitivity analysis. This is actually based on the parameters set by this author near 2011. This process is also called one at a time. So from the word itself, we'll be inputting the data one at a time. So that is the OAT method for sensitivity analysis. Simple. So this actually works by conducting multiple runs or model runs. This one, model runs. So in this case, I have 28 overall model runs. So if you know, for in the suitability analysis, this actually works by conducting or like running 28, a total of 28 suitability maps or suitability analysis. So that takes a lot of time for this sensitivity analysis. This actually um, are the parameters 10, 30, 50, and 70. For the first model run, our degree of influence for proximity to roads is 10%. You have to make sure that each of the criterion here should equal to 100 minus 10 divided by the number of criteria. No? So in this case, that is 6. So 90 divided by 6, that is actually 15. For the next model run, the degree of influence for the roads is 30. So you have to make sure that the influence in each of the criterion should be equal to 100 minus 30, that is 70, right? Divided by 6. So that should equal to approximately 12. So each of the criterion should have 12%. The same concepts being applied in 50 and 70 weighing schemes. So you do this 4 model runs each criterion. No? So 1 to 4 is proximity to roads, 5 to 8 is distance to residential areas, and slope, IULC, so on and so forth. So you also have to make sure that this table is ready. You have to make this table for you to be guided further. So that is the structure or like the format. Next up is that we proceed to the weighted overlay analysis. So we go to the spatial analyst tool, overlay, and weighted overlay. So you already are familiar with this, I assume. Just have to click the plus icon, input all the raster in your layers. So, so in the weighted overlay, so you see here the weighted overlay table. I assume that you already know how this table works. What is field value and scale value. So in my study, I have 5 classes in each of the criteria, and then I assign the rankings of each class now based on my study, and this will be inputted in the scale value. So say for instance, if you have 10% influence in roads, the other criteria should have 100 minus 10, so that is 90. 90 divided by 6 is 15. You have to make sure that the rest of the criteria should be equal to 15. You put it in the percent influence. So we're done. And then we have to make sure also that your evaluation scale is at 1 to 9 by 1. So after that, before pressing OK, for you not to be um, inputting again from scratch, from square one, you have to press this save table, and then you save it based on your preference. So in this case, since it is roads 10, you have to input it as roads 10, like that. We save. So we already saved that, no, in roads 10, and then this is the time now that we're going to press OK, then close. You have to rename it also to roads 10, for us not to be confused, since we'll be running multiple model runs ahead. So press weighted overlay again, and you will not be worrying anymore by like adding one by one again from square one, since this will be really time consuming. From our save table, we press this icon, load table, and let's look for the file that we saved. So that is 10, this one, then load. So automatically the data will be displayed. You will not be anymore typing or like importing each of the raster again, no? So after 10% for the rows, the next influence is 30%. So the other criteria should equal to 100 minus 30, that is 70, and 70 minus, I mean 70 divided by 6 is approximately equal to 12. So make sure that we input 12 in the other criteria. So now that we have the influence now, but there is an error since it is not equals to 100. So we have to make sure that should be equal to 100, and since this process does not take decimals, no, so we're just going to assign random 2 11s from two criteria for it to be equal to 100. That actually has very slight difference in the result now, so that should be okay. So after that, we press OK, and then you close it. We see here the result, and let's rename it to okay, it's 30. So you do this basically another criteria. It should have 10, 30, 70, and 50 degree of influence. So you do this for a total of 28. So a total of 28 runs for my study that has 7 criteria. If your study has 6 criteria, that should only be 24, right? 24 model runs. So after running all the 28 model runs, we now have generated a total of 28 raster layers. So the next step we do is to convert this raster to polygon. So from conversion tools, expand it and go to from raster and click on raster to polygon. And then we input raster. For our convenience, let us just stick to roads 10. And we simplify. No, it will not be simplified. So we prefer to not simplify so that it will not be, I prefer to, so that it will just conform to the actual result, on our raster. So the cell edges will just be quite like the same from our generated raster layer. And you click OK. Then we close. Let's go to the attribute table. So we have to make sure that it is arranged in a manner that it will be presented only. The object IDs will just only be 5 classes, since we have 5 classes in our study. And then to do this, we will be going to geoprocessing, dissolve, input the polygon, then click on the grid code, since the suitability classes were located in this column. So we click OK. then close, go again to attribute. So this is the final table. So we can see 5 classes here, and then column for our area. So we'll be using this column for our sensitivity analysis in Microsoft Excel. What we're gonna do is that we copy this. I think it is represented in square meters units. So we copy this one, we paste it in our Excel. You actually, I think you might need to copy this formatting, no, for our area. So we copy in this cell, and that is the area for the first class, no, that is for not suitable class. So we copy and paste again for 2, and then for 3, and then 4, and the sum just going to be the sum of these numbers. So press enter. And then what we're going to do next is to divide the value. We're going to get the percentage, no? Divide this value to the sum, and we're just going to lock it. Enter. So that's good. And then another column for times 100, actual percentage. Wait, are we doing it right? No. Times it, times. Oh, that is times, sorry. Times 100. Then, that's that. Make sure it's ano lang. So that is 100. Okay. So, we do this to other what do you call this one? Influence. So after rows 10, you have to proceed to rows 30, then 50 and 70, so on and so forth. So after inputting all the values for the succeeding influence 30, 50, and 70, we're now going to make another table. So you just have to copy this formatting. The columns present the suitability classes. In this case, we have not suitable, less, moderately suitable, highly suitable. So not suitable is represented by 1, less is 2, and then moderately 3, suitable 4, highly suitable 5. So these are the numbers 1, 2, 3, 4, 5. Then these rows present the degree of influence. So we have 10%, 30, 50, and 70. We start by inputting the cell that corresponds not suitable at 10%. So we see that this cell is at not suitable at 10% rows. So we click on that cell, then enter. Then for 30% not suitable, this is the cell. Let's click on that, then enter. 50% not suitable, this one. 70% not suitable. And then for less suitable, we have here this one. And then for less suitable at 30, that is this. For less suitable at 50%, is this one. Less suitable at 70, moderately suitable for 10, so 3, that is this. Moderately suitable at 30 is this one. 30, okay, this one. Moderately suitable in 50 is this one. 3. For 70, this one. And then for suitable is 4, so this one. For 10%, for 30%, and then Line. So we already have inputted all the values, the present values. So next thing that we do is to create the chart to um, for better interpretation of the data. So we just highlight this and click on Alt F1. We can now generate the chart, and I prefer to use line chart for easier interpretation of the data. So select line, then this one, and click OK. So it's now being arranged in um, wait, it's just so this is now the chart. I'm just going to rename it as roads, or like proximity to roads. Then I click on enter. Now this is the resulting chart, or like the sensitivity chart for proximity to roads. Now in order to interpret this chart, the concept is that the gentler the slope, the less sensitivity is to varying changes. And if otherwise, like the steeper the slope or the more irregular is the trend of the slope, the more sensitivity is to varying changes in parameters or values. So this is important in decision making, since if we see a sensitive criterion, a slight change in the values or parameters will cause a noticeable change in the results, or like in the resulting suitability map. So that is the concept of sensitivity analysis. Basically, you do this process in all of the remaining criteria. So that's it for our video, and thank you for watching. Have a good day.